Hello students, welcome back. We completed just about everything here except for one topic, some exponential and logarithmic equations. I'm talking about this one here in section 1 and this one here in section 3. Now some students may have already gone through these through the optional video. Many people may have skipped. For those people, let's go ahead with these again, but as I already told you in that optional video, these problems are rather trivial. I mean, you're not going to see these kind of problems in the exam. These are just trivial problems, exceptionally simple problems, serving only stepping stones towards something bigger, kind of like these. So let's treat these as stepping stones. By the way, we have some exponentials and fractions, so some bigger fonts will be necessary to read these better. So how to handle these? Well, can you rewrite 81 as a power of 3? 81 is 9 times 9, so it's 3 to the 4th power, but it's in the denominator, so you can rewrite it as negative 4th power. Then what do you have? We have the same base, so we can compare the exponents, and then we have 2x minus 1 is equal to negative 4. Solving this equation, you're going to get your x value, and that's what we have here. The solution and the checking process. I don't need this any longer. Okay, very, very simple, nearly trivially simple. How about this one here? Again, the same idea. 2 to the y power is equal to 4 to the y plus 3 power. But then again, 2 and 4 are intimately related to each other. That's 2 to the 2nd power. So we can use the exponent rule, multiply the powers, 2, and then 2 times y plus 3 power, which is 2 to the, let's see, 2y plus 6 power. Is that right? I just used this rule here. Multiply the powers if we have the same base. Yes, we have the same base, 2, so we can always do this. And compare the powers. What do you have? Y equals 2y plus 6. Solving this equation, you're going to get your y value. Here's a solution. And here's a checking process. All clear, right? As I said before, those are just stepping stones. They're really simple because we can take only the same base. In general, however, life is not that simple. And even worse. Okay, let's start from this one. This time, let's slow down and do this all by one step at a time. I'm not going to speed up the way I did this previous problem. I mean, this problem here, because these are, well, what can I say? Those are just stepping stones, and those are just optional problems, not really worthy of class time. Okay, maybe in terms of class time it's okay, but not really worthy of exam level consideration. This one is a little bit different because we have two different bases, so we do need some heavy use of inverse functions to get some simplification. So what do we have here? Let's copy and paste. Okay, that's the structure, and what I have to do is to apply the same thing to the left-hand side and right-hand side to make it simpler, but especially the left-hand side should be simpler. That's where we have x, so left-hand side should become simpler. More precisely speaking, I want to kill off this exponential part. The right-hand side is okay because that's just a number, so no matter what I do to the right-hand side, it's going to be just a number. Maybe some complicated number that I need some calculator, but that's about it. The left-hand side we have x, so that's something we have to work on. So how do we kill off this 2 to the whatever power? Well, remember the inverse, exponential versus logarithmic, so that they cancel each other out. Exponential log cancel each other out. Log and exponential cancel each other out. Looks like that's what we'll have to do, where a value is, what's the a value here? A value should be 2. You see, base is 2. So that's what I'm going to do. Here, I'm going to take log base 2, and because I did something to the left-hand side, I have to do exactly the same thing to the right-hand side as well. And there goes the first step. And that's how I kill off an exponential function in general. Previously, we had the same base, so we didn't really have to go through all this inverse function detail. Just compare the powers and that was it. But this time, we really have to use this inverse function business, using logarithm to kill off the exponential. So, log base 2 and this 2 cancel each other out, and you just get 4x minus 1 in the left-hand side, and right-hand side, that's it. And this one here is just a number. And if you use your calculator to calculate log base 2 of 3, let's see, log of 3 over log of 2, you're going to get 1.508 something if you use the conversion formula, change of base formula to calculate log base 2 of 3. But I don't care as a matter of fact. This is precise expression, so that's good enough for me. What I want to do is to solve for x. So let's flip this one to the other side. 4x is equal to 1 plus log base 2, 3, like this. Yes, I could have rewritten as this, plus 1 like this. But in this case, am I doing log of 3 plus 1 or log of 3 plus 1? It's a little bit unclear. So usually it's better to have it here to the left so that you can completely eliminate any possibility of confusion. Okay, let's take one more step and then I'm going to get the answer. Divide by 4, right? Divide by 4. And there goes the complete solution. And if you punch into calculator, you're going to get something, but to tell the truth, I don't care. That's the answer key, and that's a precise answer. If you want to find out 1 plus log of 3 over natural log of 2 using the conversion formula, 4, and then calculate this value, you're going to get 0.646 something, but nobody cares about that actually. The precise expression is always more desirable. Remember, how do you kill it off exponential? How do you kill off exponential? By taking the log function. Okay, there goes a full solution. Now, how about the next problem? This one is a log equation, and what we want to do is to find out what ln of x minus 3 is, and then we'll try to remove that natural logarithm. See the idea? See the strategy? So, okay, the first step is solve for this ln of x minus 3. So let's begin with copying and pasting this thing. And then let's remove the denominator first. Remember, step 1 denominators, step 2 parentheses, and step 3 like terms. That's the standard order. Everybody remembers all those? So multiply that denominator to both left-hand side and right-hand side, this is what you're going to get. Let's put some space in between. So multiply this denominator to the left-hand side, that's killed. And multiply that to the right-hand side, yeah, we get this expression. And we now have some parentheses to break up. Step 1 denominator done. Step 2 parentheses. Okay, let's go ahead. Break up this parentheses. 1 equals to 6 plus 2 log of x minus 3. Did I distribute okay? 2 times 3, 6. 2 times log, we get that. And all you have to do is solve for log of x minus 3. Okay, flip this 6 to the other side. What do you get? 1 minus 6 is equal to 2 log of x minus 3, and 1 minus 6 is negative 5. Okay, so dividing by 2, I'm going to get this. Does it look okay? Log of x minus 3 is negative 5/2. Now, by this time, some students may get exhausted. You did all these things to find out, and then negative 5/2. Is that the answer? No, not really. You have to find out x, but you found only log of x minus 3, so you still have to solve for x. How do you do that? How do you kill off this natural log? Well, exponential of log cancel each other out, we get x. And here, log base e is there, so you have to take natural exponential. Natural exponential of natural log of x minus 3 is equals to natural exponential of negative 5/2. E to the negative 5/2, no matter how complicated, it's a number. As a matter of fact, you can use your calculator to find out precisely. 0.082 something something. Did I say precisely? Sorry, approximately. Precise expression is this one. But then again, remember, what is the purpose of this? Log and exponential. Killing these off, that was the purpose, wasn't it? That's why we took the exponential. So x minus 3 is equal to e to the negative 5/2. We're almost there. And flip this 3 to the other side. Finally, we're going to get x value. X equals to 3 plus e to the negative 5/2. That's going to be the answer. Again, I could have done it like this exponential plus 3. Well, in this case, it's not that confusing, but if you use handwriting, then is it negative 5/2 plus 3 or not? It's a bit confusing. So it's more desirable to have addition to the left and then keep the more complicated thing to the right. So x is 3 plus e to the negative 5/2 power. And there goes the full solution. So we went through a couple of equations, one exponential equation and one logarithmic equation. And we went through the cancellation process, how to kill off this log by taking the exponential, actually how to kill off this exponential by taking the log, and how to kill off this log by taking exponential. So base 2, so log base 2, and natural log, so natural exponential. That's how you do it. Okay, so much for lesson 11.